Press the upper button on the bimalleolar clamp. Engage the support in the groove. When the neutral position is reached, release the button. Turn the wheel of the tibia alignment handle to the open position. Open will be displayed. Engage the handle onto the bimalleolar clamp. Close the wheel. Push on the handle adjusting wheel to release the locking mechanism. Engage the holding rod in the handle. Release the wheel when the desired level is reached. For a standard approach, engage the holding rod in the central connection square of the tibia cutting guide. Lock the assembly by turning the frontal wheel. For fixation, the highlighted pinholes are used. In case of a less invasive approach for the right knee, engage the holding rod in the hole marked with R. For fixation, use the highlighted pinholes. In case of a less invasive approach for the left knee, engage the holding rod in the hole marked with L. The connection square of the stylus is engaged in one of the connection squares of the tibia cutting guide. The connection is fixed by locking the wheel on the stylus. The proximal fixation is put through the proximal opening of the holding rod. Turn the tab into a horizontal position to fix the assembly. By opening the fixation wheel of the handle, the alignment system can be shifted in AP direction in order to increase or decrease the slope of the proximal tibia resection. Pushing the knob at the bimalleolar clamp and sliding the alignment system medially or laterally allows to adjust the varus valgus of the proximal tibia resection. The distance between the laser-marked lines on the scale corresponds to a 1-degree adjustment for a 40 cm long tibia. For a rough height adjustment, press the adjusting wheel and move the assembly up and down. When turning the wheel, cutting height can be fine adjusted. The planned cutting height is set on the stylus. The alignment system must then be adjusted in height until the stylus is in contact with the desired reference. Push the button of the T-handle to couple it with the intramedullary alignment rod. Connect the tibia orientation sleeve to the intramedullary alignment system. The 0-degree orientation sleeve indicates a 90-degree tibia resection in relation to the intramedullary canal. A 3-degree posterior slope is integrated in the gliding surfaces. For referencing the tibia cut height, attach the tibia stylus to the orientation sleeve by clicking in. Engage the assembly in the central connection square of the tibia cutting guide. For fixation, use the highlighted pinholes. In case of a less invasive approach for the right knee, engage the holding rod in the hole marked with R. For fixation, use the highlighted pinholes. In case of a less invasive approach for the left knee, engage the holding rod in the hole marked with L. For fixation, use the highlighted pinholes. The assembly is slided over the intramedullary rod. To check the assembly's alignment, an alignment rod can be used. The resection level is adjusted by turning the wheel. Connect the distal femur contact plate to the intramedullary alignment system. Choose the appropriate orientation sleeve in 5, 6, or 7 degrees according to the preoperative planning. 8 and 9 degrees are optionally available. The assembly is slided over the intramedullary rod. Engage the assembly in the central connection square of the distal femur cutting guide. The standard resection level is 9 mm according to the distal femur implant thickness. Before the femur alignment block is passed to the surgeon, both parts are prefixed with the screw. The lateral anterior cortex can be palpated using the stylus to avoid the risk of anterior notching. The stylus can be adjusted in proximo-distal direction in order to get a congruence between the AP sizing and the proximo-distal sizing, indicated by the scale on the upper part of the stylus. By tightening the screw, the stylus position is fixed. The rotational position can be confirmed by using 2 pins in the sidewise holes of the femur alignment block with reference to the epicondyles. Alternatively, the white sides line can be checked through the slot at the middle of the instrument. It is possible to adjust the external rotation by manipulating the posterior lever arm, clockwise for right knees, anti-clockwise for left knees. Rotation is fixed by tightening the screw at the bottom lever arm. In order to fix the AP size, the upper screw can be tightened as soon as the tip of the stylus reaches the desired landmark on the anterior cortex. To check the anterior femur cut level, the cutting check plate is inserted in the guiding slots of the instrument. After the trial tibia plateau has been positioned and fixed on the proximal tibia cut, the guiding tower is placed on it by engaging the posterior teeth first. Now, the handle can be reattached to the assembly to lock it. According to the planned tibia size, the corresponding tibia drill sleeve is placed on the guiding tower. The drill with stop is first used to prepare the bone for the winglet chisel. The wing stem preparation is performed by using the winglet chisel connected to its handle through the guiding tower down to the stop. For every tibia size, there is an own winglet chisel, as the tibia wing stem of the final implant is growing by size. The thickness of the patella is measured using the caliper. This thickness should not be exceeded after implantation of the patella implant. The level of bone resection is calculated. A minimum thickness of the remaining patella bone should not be less than 12 mm. The patella is fixed into the patella resection clamp. The resection level is adjusted by turning the resection depth wheel to the planned level of remaining patellar bone thickness. By turning the screw, the position of the patella resection clamp is fixed. With a 1.27 mm thick saw blade, the resection is performed through the cutting slot. Then, the patella drill impaction clamp is set onto the osteomized patellar surface. The peg holes for the implant are drilled through the holes with the 6 mm drill until the stop is reached. The size of the patella is determined with the corresponding trial patella implant. The patella is implanted using the patella drill impaction clamp and the concave plastic cap, which allows good transmission of forces during the cement hardening process and at the same time protects the patella implant against damage.